Let's say we had x squared plus 2x plus 4 is greater than 0. Well, unfortunately, that doesn't factor. So to handle that, I have to use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, that would be negative 2 plus or minus the square root of 4 minus 4 times 1 times 4 over 2 times 1. That's negative 2 plus or minus the square root of negative 12 over 2, which is negative 2 plus or minus 2i square roots of 3 over 2. Now, technically speaking, I could simplify that, but the moral of the story is that's imaginary. And since that's imaginary, where would I put that on the number line? It can go on the number line. So in reality, there's only one region on this number line, and I can pick any number I like to plug in and see what happens. So let's say I plug in 0. So if I put 0 into there and there, I'm going to get 0, and then I'm ultimately just going to end up with positive 4. The moral of the story is this is positive everywhere, and since I'm looking at greater than 0, I basically want everything. So this would be negative infinity to infinity. The assignment that goes with this part is on page 563, 24 through 42 even. Now we haven't done anything with rationals, so let's look at this. So let's say I have x minus 2 over x minus 1 times x plus 3, and that's less than or equal to 0. Now notice this is factored. If it weren't factored, you would need to factor it. And once you factor it, you can figure out where the top part's 0 and where the bottom part is 0. And it's very important to pay attention to those, where they come from. So in this case, I'd have positive 2 from the top part, positive 1, and negative 3 from the bottom part. So, negative 3 is here. I can put 1 here, and I can put 2 there. Now, when I do these dots, it's going to be very important to understand. Anything that comes from up here, the dot matches what goes here. So, since this one is less than or equal to, the one at 2 gets a closed dot. However, division by 0 is bad. So when those two are 0, the whole thing's undefined. So no matter what the inequality says, the ones off the bottom are always open. And now it's just a question of plugging in. You've got 4 regions to test, so let's test them. If I pick a point from the left, say negative 4, negative 4 minus 2 is negative. Negative 4 minus 1 is negative, and negative 4 plus 3 is negative. So if you have an odd number of minuses, that makes a negative. Now let's pick a point from this piece in here. Guess I need to indicate which one I'm talking about. Say 0. 0 minus 2 is negative. 0 minus 1 is negative. 0 plus 3 is positive.
Eric and Nathan Reaper can come to the dog collar. Your mom's waiting to pick you up. Eric and Nathan Reaper, come to the dog collar. Thanks.
Wow. So anyway, where was I? So negative, negative, and positive, you got an even number of minus signs, so those cancel, and that makes positive. Now let's pick a point from in here. Say 1.5. 1.5 minus 2 is negative. 1.5 minus 1 is positive. 1.5 plus 3 is positive. Overall result there would be negative. And let's pick a point from the right. Say 5. 5 minus 2 is positive. 5 minus 1 is positive. 5 plus 3 is positive. Overall result is positive. Now, I want this to be less than or equal to 0, as indicated by this guy right here. Or I guess I could draw a box around it if I wanted to make it big. But anyway, so less than or equal to 0 means I want negative. So I want that piece, and I want that piece. So I've got negative infinity to negative 3, union 1 to 2, like so. The assignment from this part is on page 564, and on page 564 I need 74 to 84 even. Thank you very much.